Hi everyone! In this video we are going to identify the pairs of trigonometric functions that are equal in value for the acute angles of a right triangle. Let's consider that the acute angles of our right triangles are theta and beta. We have that in this triangle the opposite side of theta has length A and the opposite side of angle beta has length B and the hypotenuse is equals to C. We have that the sum of the inner angles of a triangle is equals to 180 degrees. So we have that theta plus beta plus 90 degrees is equals to 180 degrees. So if we subtract 90 degrees from both sides of this equation, we have that the sum of theta and beta is equals to 90 degrees. Two angles whose sum is equal to 90 degrees are called complementary angles. In this case, we have that the theta and beta angles are complementary angles. Now let's identify which pairs of trigonometric function we have that are equal for both beta and theta. Let's start with sine function. Sine function of theta, so sine of theta, is defined as the opposite over hypotenuse. So the opposite side of theta has length A, so we have A over the value of the hypotenuse, which is C. Note also that we can identify the cosine of beta as also A over C, because cosine of beta is adjacent of beta divided by the hypotenuse. Adjacent of beta is A and the hypotenuse is C. We have that sine of theta and cosine of beta are equal. In a similar fashion, we also have that sine of beta is equals to cosine of theta. Now let's take a look at the tangent of theta. So tangent of angle theta is defined as the opposite of angle theta divided by the adjacent of theta. So the opposite of theta is A, the adjacent is B. If we take a look at the cotangent of angle beta, we have that the cotangent is defined as adjacent over opposite. And for the angle beta, adjacent is A and opposite is B. So this is the second pair of trigonometric functions that are equal in value for the complementary angles. So we have that tangent of theta is equals to cotangent of beta. And again, if we switch, we also have that cotangent of theta is equals to tangent of beta. So for two complementary angles, so far we identified that one pair of trigonometric functions is sine and cosine. The other pair of trigonometric functions is tangent and cotangent. So for these pairs, we have that they are equal in value for complementary angles. Now let's start with secant. Secant of angle theta, which is defined as hypotenuse over adjacent. We have then that for theta, hypotenuse, which is C, divided by adjacent, which is B. We have that cosecant is defined as hypotenuse over opposite. For angle beta, we have then that cosecant is C over B. Therefore, the third pair of trigonometric functions that are equal for complementary angles is secant and cosecant. Secant of theta equals cosecant of beta. And again, if we switch the angles for this trigonometric function, we also have the equality. Secant of angle beta is equal cosecant of beta. Now we can rewrite these trigonometric relationships in terms of a single angle. Because the sum of theta and beta is equals to 90 degrees, we can describe beta as 90 degrees minus theta. Looking back at the relationships that we have, for example, sine of theta equals cosine of beta, we can rewrite that in the form of sine of theta equals to cosine of beta, that now I'm going to use the relationship of theta as 90 degrees minus theta. In a similar fashion, we can rewrite the same way the tangent of theta equals cotangent of beta. So tangent of an angle theta is equals cotangent of 90 degrees minus theta. And secant of theta being equals to cosecant of beta can be written as secant of theta equals cosecant of 90 degrees minus theta. We can adopt the trigonometric identities from degrees to radians. Supposing that the angle theta is given in radians, we can rewrite these trigonometric identities in radians. So we have that sine of theta is equals to cosine of pi over 2, which is equivalent to 90 degrees. So pi over 2 minus theta. We also have the tangent of an angle theta given in radians is equals to the cotangent of pi over 2 radians minus theta. And finally, the secant of an angle given radians is equals to cosecant of pi over 2 radians minus theta. Now that we discussed the pairs of cofunctions, we're now going to use them to evaluate the following. We're going to find the cofunction with the same value as the given function. So for number 1, we have cosine of 50 degrees. Recall that sine and cosine are cofunctions, and we have that sine of an angle in degrees is equals to cosine of 90 degrees minus the given angle. Because sine and cosine are cofunction, we can also write that cosine of theta is equals to the sine of 90 degrees minus theta. We are going to use the second version to write cosine of 50 degrees in terms of the cofunction. So we have that cosine of 50 degrees is equals to sine of 90 degrees minus 50 degrees. We have then the cosine of 50 degrees is equals to sine of 40 degrees. For problem number 2, we have tangent of 15 degrees. To write tangent of 15 degrees in terms of its cofunction, we have that the pair of functions tangent and cotangent are cofunctions. So tangent of an angle theta is equals cotangent of 90 degrees minus the angle. We can also rewrite this for cotangent. So we have the cotangent of an angle theta is equals to the tangent of 90 degrees minus theta. We can use the first equation to write tangent of 15 degrees using its cofunction. So tangent of 15 degrees is cotangent of 90 degrees minus 15 degrees. Therefore, tangent of 15 degrees is equals to cotangent of 75 degrees. Now, let's take a look at number 3 and 4. For both problems, we have that the angles are described in radians. So recall that the corresponding cofunction to secant is cosecant. So secant of an angle theta is equals to cosecant of pi over 2 radians, which is equivalent to 90 degrees, minus the angle theta. We could also write this for cosecant. So cosecant of an angle theta is equals to secant of pi over 2 minus theta. Because we have to write secant of pi over 5 in terms of its cofunction, we use the first equation. So we have that secant of pi over 5 is equals to cosecant of pi over 2 minus pi over 5. We now have to subtract pi over 2 minus pi over 5. The LCD is 10. So we're going to multiply the first equation by 5, top and bottom by 5. So we get the denominator 10. And we're going to multiply the second equation by, we're going to multiply the second fraction by 2, top and bottom. So the LCD will appear in the denominator. So secant of pi over 5 is equals to cosecant of 5 pi over 10 minus 2 pi over 10. Therefore, we can conclude that secant of pi over 5 is equals to cosecant of 5 pi minus 2 pi, which is 3 pi, over 10. For problem number 4, we have that sine of 3 pi over 7. We just wrote that sine and cosine are cofunctions, and again, reminding the equation that describes the relationship of these two cofunctions, we have that sine of an angle theta is equals to cosine of pi over 2 minus the angle theta. Because theta for us now is 3 pi over 7, we have that sine of 3 pi over 7 is equals to cosine of pi over 2 minus 3 pi over 7. Now, doing the subtraction of the two fractions, we needed the LCD, which is 14. So we're going to multiply the first fraction by 7, top and bottom, and the second fraction by 2, top and bottom. What we have now is that 7 pi divided by 14 minus 6 pi divided by 14. Because both fractions have the same denominator, we keep the denominator and do the subtraction in the numerators. So we have that this is cosine of 7 pi minus 6 is pi, so we have pi over 14.